All right, let's look at homework number 4, problem number 4. I will try to help you get started on this one. All right, so as a hint, substitution is already given. So v is equal to 4x plus y. All right, so in this case, in the notes, I said when v equals ax plus by plus c. Right, so in this case, a happens to be 4, and b happens to be 1, and c happens to be 0. Right, but anyway, let's use that suggestion to turn this into something we can manage. All right, so let's start with, so we're going to say let v be 4x plus y. All right, so if that's the case, we can rewrite this dy over dx as v squared. Right, because this is the guy we call v. Right, then we're going to take the derivative of this substitution. Right, so let's find dv over dx. Right, so this is going to be derivative of 4x is just 4. And derivative of y would be dy over dx. Right, so we already know that this guy is v squared. So you're going to have 4 plus v squared. Right, so let's clean up the equation. So you're going to have this equation. All right, so you have a dv over dx is equal to 4 plus v squared. All right, then this is remember, this is a separable equation. Right, so since this is a separable equation, we can probably put all the v's on the left and all the x's on the right. So let's do that. All right, so we're going to divide through by quantity 4 plus v squared. So you will get 1 over 4 plus v squared and dv over dx, and this is going to be equal to 1, right? All right, then we can just integrate it with respect to x. So you see that you have an integral with respect to x, and integral and with respect to x. Right, then you can cancel out, you can cancel dx on top and dx on the bottom. That way we have an integral with respect to only v, and you have a fairly easy integral on the right. All right, so you might want to use something, integral rule. That was if you have 1 over a squared plus say x squared dx. Right, so I think this is one of those arctangent, right? So this goes something like a 1 over a arctangent of x over a plus some constant c. Right, You might want to use that to evaluate the integral on the left. On the right, it's pretty easy. All right, I think you can get going from here. All right, that's it. I hope that this was helpful.